In this video, we want to consider what happens when the absolute value operation is brought into a linear equation with one unknown. So let's consider the absolute value of 2x plus 3 equals 4. So notice I said the absolute value operation. So we have now added a fifth operation, the absolute value operation. So it's the fifth one because we've talked about addition and subtraction, and then we've talked about multiplication and division. So the absolute value operation is something that is totally different from either one of those. In order to understand the absolute value of 2x plus 3 equals 4, let's first consider what would happen if simply the absolute value of x were to equal 4. You have probably seen that the solutions to that would be that x could be 4, or x could be the opposite of 4, negative 4. The absolute value operation takes the value that you put in, and it gives you the distance of the value from 0. So if we were to consider a number line, the number 4 is 4 units to the right of 0. So its distance from 0 is 4. The number negative 4 is also a distance of 4 units. It's to the left this time, but it's also a distance of 4 units from 0. So its absolute value is also 4. So either one of these are 4 units away from 0. Now, how does that apply before we move on, let's consider the word or. It's very important as we talk about logic. The first two things that get introduced are the statement or and the statement and they are very different from each other. We could have a solution of x being 4 or x being negative 4. We cannot have a solution that x is 4 and x is negative 4. You couldn't have both things occur at the same time. And requires that the things are simultaneously true. And you can't simultaneously be a value of 4 and be a value of negative 4. The or statement allows one or the other to be true. So you could have a value of 4 while not having a value of negative 4, or a value of negative 4 while not having a value of 4. Now let's go back to the original problem. Based on what we just discussed, if the absolute value of 2x plus 3 is 4, then 2x plus 3 could, in fact, equal 4. And its absolute value would be 4. Or 2x plus 3 could be the negative of 4. Let me write that a little more clearly. Now, for either one of these, the solution should be pretty straightforward at this point. For either one of these, subtracting 3 from both sides will simplify the equation. We'll divide both sides by 2, get that x is 1/2. We can do the same thing in the other equation. And get that 2x should be negative 7, so x would be negative 7/2. Work through those more quickly than in the past, but these are the two solutions that would work. There are other ways to arrive at these solutions, but I think those are the simplest ways to do it. So what does this mean? If we put 1/2 in for x, the absolute value of 2 times 1/2 plus 3 would equal the absolute value of 1 plus 3, which is equal to the absolute value of 4, which is 4. And clearly the original expression needed the left-hand side to equal 4, so this would make the statement true. If we were to substitute in negative 7/2, 2 times the negative of 7/2 plus 3 would be equal to the absolute value of -7 plus 3, which is the absolute value of -4, which in fact is 4. So whether we put 1/2 into the original expression, or the original equation, or -7/2 in, either one will make the original equation true. So we have two possible solutions now instead of one, like we did when there were no absolute value signs. So let's consider another variation of this. Let's consider the problem 2x plus 3 equals -4. Now you may think I didn't leave much room. That's very intentional, because let's go back over to considering what the absolute value means. If I wrote the absolute value of x equals -4, there is no solution. Why is there no solution? You can give me any number you want and you cannot get its absolute value to be -4. If you put 4 in, the absolute value of 4 would be 4, so that doesn't work. If we put -4 in, its absolute value is 4, and 4 does not equal -4. So an absolute value operation can never return a negative value. So when I say the absolute value of 2x plus 3 needs to equal -4, you can simply write no solution. There are no values of x that will allow the quantity inside of the absolute values to come out to equal -4. So let's move on to another example that does work. So always be aware that you could have no solution when you're working with absolute values. Let's consider a variation on the problem we originally looked at. Let's take 2 times the absolute value of x plus 3 equals 4. Let me write that a little more clearly. 2 times x plus 3, absolute values, equal 4. So this is different because the 2 is a factor outside of the absolute value signs. So when you have a problem like this, don't break this into two parts with the or statement until you get down to the absolute value signs on one side of the equation or the other. What we want to do in this case is we want to divide both sides of the equation by 2 first. And since we have a factor of 2 on the left-hand side in the numerator and a factor of 2 in the denominator, the 2's can divide out, and we are left with the absolute value of x plus 3 must equal 2. Now we can remove the absolute value signs and say that x plus 3 must be 2, or, keyword, x plus 3 must be the negative of 2. If what's inside of the absolute value signs comes out to equal 2, its absolute value is 2, or if what's inside is equal to -2, its absolute value will still be 2. So now, I think it's fairly clear, we would like to subtract 3 from both sides and get that x is equal to -1, or if we subtract 3 from both sides here, x could be -5. Either one of these should make the original equation true. So let's check this out. 2 times the absolute value of -1 plus 3 equals 2 times the absolute value of 2, which equals 4, which is what the right-hand side of the equation was. If we substitute on the left-hand side of the equation, so we could say, let's just leave that blank. Now let's look at the second side. Let's consider the solution -5. So 2 times the absolute value of -5 plus 3 must equal 4. So this time we get 2 times the absolute value of -2 must be 4. So 2, the absolute value of -2 is just 2, must equal 4. So 4 does in fact equal 4. So that value works out as well. So either -1 or -5 will be solutions to this particular problem. Let's consider one final variation on this. What if we had looked at absolute value of 2x plus 3 equals 4? This time the plus 3 is outside of the absolute value signs, so we would want to subtract the 3 before removing absolute value signs. So we would have the absolute value of 2x should equal 1, and so the absolute value, so therefore 2x could be 1 or 2x could be negative 1. Dividing both sides by 2 mean that x could be 1/2 or x could be negative 1/2 in this case. One final little trick, watch out. If this had been the absolute value of 2x plus 3 equals 1, when we subtracted 3 from both sides, we would get the absolute value of 2x must be negative 2. As soon as we see that something in absolute values must equal a negative value, we can immediately conclude that there is no solution. So just as you're doing problems, be aware that absolute value functions can result in having 2 answers instead of 1, or possibly no answers instead of 1.